So this is the battery and wiring assembly. This is the batteries being charged in an X-Star lithium ion battery charger. These are 18650 batteries. I'm using Sony VTC6 batteries. They're 3000 milliamp hours with a maximum 20 amp output. They go from 4.2 volts maximum to 3.7 nominal. This is the holders. These are pretty cheap to buy from AliExpress or one of these places. They're very basic 18650 battery holders. And that's me bending the terminals down on all of them. If possible, you want these bendy bits down, and then you want to snip off the ends but still have a piece of metal that goes over the top of the other metal on the other battery case. That one snapped off. Doesn't matter if they snap off because you're going to be soldering a nickel strip across them anyway, but it just makes them that bit more solid if you can leave the small piece intact. So I'm just using a Dremel tool here to take off the rectangular piece. Half the time it just snaps them right off anyway, but if you can leave the short piece intact. Be sure to use eye protection when you're doing this. These little pieces can fly right up. If you don't have a Dremel tool, just snap them off. I'm showing you here how they're going to go together. So that's how they're going to be inside the battery casing that's underneath the foot platform. So I'm just gluing them here. There's actually a little notch or a little extrusion on each of these cases that you really need to take off with a Dremel to make them fit flush together. So if there's anything, just check the backs to see they should go together nicely. I'm just using some pliers to, you can't really see it here, I'm just crunching them together. You gotta be quick with the super glue. Just realise there's a couple of notches there, so just get rid of the notches. And then they go together. Two notches gone. That's it. That's them right together. When that super glue dries, it'll be solid. So this is me now cutting a notch out so that we can put our nickel strip in between these terminals. And there's a couple of different ways you can do this. I'm doing it here with a sort of cutting wheel. So I'm just cutting down. See, I want to cut a rectangle out from one terminal to the other. I think the nickel strip's 6mm wide or so. The part specifics in the parts list. It has to be a certain size due to the amount of amps going through it. So that's it, we've notched a piece out. So we'll do this for the other one as well. You want to make sure the terminals are clean and clear. Get them all perfect. This is probably the most laborious part of the whole project, because there's so many of these battery compartments that need to be joined and soldered. It takes like all day to do it. It's a real pain unless you've maybe got a spot welder, a mini spot welder. It would be a piece of cake, but when you've got to solder on nickel strips onto terminals, and it's a real laborious, horrible task. And there's me trying to fit them together, fit these pieces. You really need to use these battery compartments as well, these little battery holders, because it's very tight in the battery compartment for the scooter. So you really need to use these. I was using ones that were slightly larger, more common ones. They're a really tight fit into the base. So if you use these, you've got a good bit of leeway. So, and they're much easier to get out as well, out from the base of the scooter. So you want to use these, and they're cheap too. I think I must have got about 30 of them or something for about £15 from AliExpress, something in that range. So me just putting them together, see me overlapping. If you can make them overlap, then it's all the better. Here's a nickel strip that needs to go on. So on one end you've got a nickel strip that goes from one side to the other, and on the other end you don't, because the other end, each of those is taken off with a wire that goes to the next battery compartment, or the next set of 4. That's me just measuring the nickel strip. Get a pure nickel strip. You don't want anything else, you want it has to be pure. You get ones that are like coated or something, they're not 100% nickel, and I don't think the cost is much between them, but you need it to be pure nickel for conductivity. Here's the other way that you can also do it. So you put them both together, and then you use sort of sanding wheel or a grinding wheel and literally just grind a channel between. But both ways make a mess, to be honest. I think just using the cutting one's probably a bit more straightforward. All I'm doing is grinding out a channel between the terminals. What you should also do before you put the terminal in, the nickel strip in, is you should buff or sort of grind at these battery terminals you can see here, just to give the solder something to key onto. Make sure they're clean, make sure there's no plastic on top of it. This is the critical part, because you've got either 26 or 30 4.2 volt batteries, and there's quite a lot of power going through, so you want these to be clear. So we just grinding the debris away, and it grinds up the terminal. This took me all day to do all of these battery compartments. It takes hours. I'm just going to slice up the nickel strips here that I measured earlier. May as well do quite a few of them, do more than enough, because some of them might be too long or too short. These again can flick up at you, so make sure you're wearing eye goggles. So that strip's got to go across there, and you want a good connection. If it's too long, cut it down or cut a fresh one. You don't want it bending up the way. If you also score the ends of the nickel strip, the two ends that meet the terminals, just use some sort of sandpaper or whatever, just to give it a key onto for the solder, because the solder's a nightmare on top of this. It just runs everywhere. This is me going to show you how to solder badly. It took me hours to do this. I'm sure an expert could do it easy peasy. Not for me. I'm using the flux core stuff, but it doesn't really make any difference. It doesn't work for me either way. So it's a case of just making sure you get lots down onto the terminals. Then I'll just put the nickel strip across it, then heat the top of it so that it melts on the underside, and just hope that it sticks. Once it sticks, I try and get some up both sides just to give it a little bit more strength. And it's really important to get these done correctly, because after I had completed the project, I realised I was running around and one of the batteries wasn't connected properly. One of these strips, it just wasn't touching enough, and it ended up one of the batteries wasn't getting used at all. You'll find that out when you go to charge them, and one of your batteries is still at 4.2 volts and the rest of them are at 3.5. This is me showing you, but it's a disaster. So perhaps best thing to do is for you to watch a proper skilled solderer on another video, rather than watch me struggle with this. Me just pressing it in, trying to melt the solder underneath. Half the time it doesn't bloody work. But you get the gist of it. You basically want a strip going from one side to the other, soldered down as well as possible. You'll need to use a meter to test the conductivity or a continuity test or whatever they're called, to make sure that, like, you know, current can flow through all terminals. From one side to the other. This is me just trying to build some up at the edges to make it more solid. Remember, it's going to be rattling about a bit when you're driving or riding. You also don't want the solder sticking right up. So if you've got a Dremel, you put the solder on, put lots on, and then you can just grind it back down, make it a bit flatter. You don't want these sticking up because you don't want them eating through the insulation tape that you put on later, with it rubbing against the side and then hitting the aluminium frame. Obviously you don't want to short circuit everything or possibly get an electric shock. Not exactly a masterpiece, but enough to do. I'm just going to do a continuity test on it, set it for the little buzzer. And you want it going across all those four corners. I've got mine set to resistance, so, but just put it to the buzzer and you'll hear it. Obviously I don't have the sound on. I'll show you. I mean, that soldering looks terrible. I'll no doubt have redone it after I've shown you this. And then there's me being a fool, trying to make it go across thin air. Amateur hour for soldering and electronics, but that's what I say, that you don't need any real skills when it comes to building this scooter. There's no real skills when it comes to electronics or electrics, or you just need basic tools, you know, as long as you can drill a bit and join a few things up, join a few wires and drill a few holes, and then you're all right. So you need them going right across both the contacts. It's a bit easier to solder wires than it is that stupid nickel strip. That's me just, you put the solder onto the wire first, let it soak into it. I'm making a hash of it here, but just let it soak into it and put some down on the surface that you're going to. When you're going from one battery case to the other, you don't really need, a lot of wire in between, but if you put them all in the first sets first, and then you'll be able to judge by just putting it on top of the battery compartment how much wire you'll need. I'll maybe just put a note on one of the drawings to let you know how long to cut the wires. What a mess. Yeah, you'd be far better looking at a real soldering video. I did myself, but obviously never learned anything. Make sure the end of the wire, you've got a nice long length on it. You want it to span both the halves of the terminal. Look at that, it's hanging off. When you're dealing with these 18650 batteries, you really have to be very careful. You want everything to be as free from debris and contacts as good as possible. You don't want any solder hanging around the edge of anything, or You definitely don't want any solder, loose pieces of solder jumping into the contact at the positive end of the battery, because if you connect the positive and negative on one of these batteries, they're so powerful that you've got like seconds until it goes on fire, basically. I've already had it twice. I've set fire to 2 battery casings already just because I wasn't paying attention. I put batteries in the wrong way around. You put one in the wrong way around, you've got about 3 seconds to get it back out, because the plastic will literally go on fire. It's astonishing how much power is in these batteries. Wow, what a length of time to solder one wire. Hopefully I'll be able to fast forward this so I don't look like too much of a fool. Taking like 20 minutes to solder one wire takes somebody in China 3 seconds to do the same thing. I'm still at it. Still at the same one. Dear, oh dear. I think I actually ended up tearing this next one off anyway after I put it on, because I needed to go the other direction. You want everything to be as neat as possible. There's not much space in the battery compartment. tell you, I wouldn't get a job working in Guangdong province, that's for sure. I'd get laughed at. God, back to the first one. Use about 1 kilometre of solder on one battery compartment. Dearie me. Yeah, after you've botched it up like this, you really want to shave down the solder. You don't want that sticking up. I would have done that after this, whether I show you it or not. Oh, here we go again. And one more, that tells you that it was working. So here I'm just filling it with batteries to show you. So the batteries are in series of, well, it's 13 or 8 or 13 or 15 in parallel of 2. So there's either 26 or 30 batteries, and that'll give you, the 26 I think gives you 48 volts. Or something around that. The controllers that I've used for this, the previous one I used was a 500 watt, and it was a 3248 volt. But the new one I'm using now, because I found out that the hub motor that I'm using for it, the hub motors can take a bit more power. So saying it was like 600 watts or something maybe. So what I did was I bought a 600 watt controller that goes up to, I think it's 48 stroke 64 volts. So to give it a bit more oomph, which seems to work, because despite having one of the batteries with a bad connection and not even connected, I don't think, I still managed to get up to 26 miles an hour off of it. So with possibly a little bit more to come, because the Hall sensors weren't working correctly either. So hoping if I get them working a bit better and that last battery connected, I can, maybe be sending it towards 30 miles an hour, especially considering my weight, which is 93 kilograms. So your standard scooter's speeds measured with a passenger of 75, which is a decent chunk lighter than me. So this is me just showing you how they connect together. So going from one side to the other. I'll probably do a drone for this, but you're just going from 2 minuses to 2 pluses to 2 minuses to 2 pluses, and then transfer across to the next compartment or the next battery holder. Just showing you them how they would go in a line. In one end, that's the negative end there. Just leave plenty of wire for feeding through up to the controller. It's me showing you where the electrons are going to flow up, across. So they're all in pairs. So you have 2 minuses, 2 pluses, and then joins to 2 minuses and 2 pluses. The minuses to the plus in pairs. There's a new controller there that I've got. The batteries, these batteries compartments as well, you have to label them, the minuses and the pluses. See, I've got them labeled there. You have to do that, because if you put one in wrong, it's on fire. So label them all, re-sleeve your batteries and label those as well, the way I've got minuses and pluses. Make it nice and big so you see it. This is me running the learn mode, so that's your learn wires there. On this particular controller, I foolishly had the 2 pink wires connected, which is a sort of speed limiter, maximum speed. But here I'm just putting on the learn. It's running the wrong way, so you disconnect it until the motor stops. When the motor stops, put them back together and they'll rotate the other way. Now it's spinning the proper direction, but it's actually going slow because I've still got the pink wires in, I think. I haven't tried to relearn it when the pink wires have been disconnected, so I don't know if there's a speed limiter in play there, but I'm going to rerun it just in case. There's my switch that I have. I'll show you how all the wiring works. So there's the motor running at full tilt. That's me just testing the voltage out for all of them. 61. I should have known that I was a bit short. One of the batteries wasn't actually connected because of my poor soldering work, so I should have known, but at this point I hadn't charged up the last 4. I was only on 26 fully charged and 4 semi-charged, so you want to get them all fully charged and test it and see what you expect out of it. That's the controller, 48 to 64 volts, 600 watts. So if you divide the 600 watts by the 64 volts, and that gives you the amount of amps it's drawing, and these batteries can run up to 20 amps, which is way over what's required. These Sony VTC6s, there's also LG ones that are the same, 3000 milliamp hours, which is, you know, quite high capacity. 3500s I think it's the most you'll get, but then again their output is only like 10 amps, and you want more than that. You need at least 15 amps on your batteries. This is me just showing you the power. So that's the battery minus and plus wires. Battery minus plus, it's the big thick ones, red and black. To accompany that, you also need a thinner orange or red wire. So this is what they call the lock wire. So you run that thinner red or orangey wire that actually connects to the positive. So that's where your switch goes that I was showing you on the handlebars. So it connects between the red, the big thick red, and the orange, slightly thinner orange. And then they both go to the batteries, black to the minus, red to the plus. And these are the the motor phase wires. So those colours will correspond on the motor. They're the thick ones that go to the motor. So you just wire them in. It doesn't matter if your motor runs in reverse, because as you saw, you can just change the direction using the learn wires. And these are the Hall sensors. It's the five thin ones. That's the ones you want to find next. 5 thin ones are the Hall sensors. This tells the controller the position of the wheel. So I think there's one or two are like sort of grounds, and then the other ones are the position. I don't know if it's 120 degrees or 90 degrees. Where the sensors are in the Hall, the Hall sensors within the motor. You don't have to run the controller. Most controllers are, you can run sensorless mode, but it's smoother. You get better torque when you're running Halls, when you run the Hall sensors. This is the learn wires I'm showing you here, the two white ones. They have a connector that allows you to connect them. So when you put them together, it's in learn mode. All you do is put the power on, connect them together, and the wheel will start spinning. If it starts juddering and shuddering, it means that your Hall sensor wires are, are going to the wrong ones on the motor. What they should do is spin all the way up to full speed. I've got those pink ones there that you can see me just going over the top of. Foolishly, I never noticed that those were connected, and they are the sort of limiter wire, so I should have disconnected those pink ones. These three here, these are the controller wires. So you've got, it's like a ground, a plus and a minus, and it sends, like a potentiometer, so it sends from the minus to the plus via the ground, and that's dependent on how much current goes through it. It's how much throttle you're giving the motor. So those three go to your thumb controller. These three here are the power settings. If you don't do anything with them, you're on high power. But if you connect these up into a three-way switch, it means you can use high and low power. So it's like low power is like half. The power of the controller only allows it to output like half or something. It's probably not even that. I mean, you don't need all these other ones. So what I did in the end, whether I do it here or not, I don't know, I just cut them all off because they take up so much room within the housing for the controller. There are things like regen braking and things like that, but when I tried it with the regen braking and nothing happens. So nothing happens with that. And if you want to use the e-brake, you've got to send power into another wire for the e-brake, and it eats up your battery power. So I didn't bother connecting that either. And that's it.